Okay, another example is the famous Schilling segregation model. It was the most instigating incident or the example of the agent-based model. And this Thomas Schilling also received the Nobel Prize. And then it's not his entire work. However, this is one iconic work that Schilling did. Okay, so known phenomena of our city neighborhood. We know that some part of the world is a bad neighborhood. Okay, so let's admit that some neighborhood would be prosperous. However, some neighborhood is not that much prosperous, and so that that neighborhood, we want to understand why this neighborhood exists and how come. Is it coming from the land price? Is it coming from some infrastructure, accessibility? Or is it coming from the residents and so forth? Let's try to find out. Okay, and then early on, the Thomas Schilling's hypothesis was this. His hypothesis was not involving any of those economic terms or price or cost or money problem. Just assumed just made one assumption that whites want to live with whites and black wants to live with blacks. Okay, it's like it is being called a segregation. One species or one race wants to live with each other, and the other race wants to live with each other. We are not going to interact with each other across the race. And that was Thomas Schilling's hypothesis. And wants to test the hypothesis. However, it is really difficult in the real world to test this hypothesis. Why is that? Because in the real world, we all have some infrastructure bias and the land price bias, and there is a social aspect or historic aspect how this urban environment is being shaped, so that our survey from the real world would not be sterilized, would not be sterile, meaning that it is not going to strip off all those biases and historic elements, artifacts, to test only this hypothesis, meaning that Schilling needed a virtual world. Okay, he built his own, and the people are reacting only according to this hypothesis. So that he built a segregation model, and this URL provides a simulator demonstration of that segregation models, right? And then this could be a good example of the agent-based model. Why? Because we have an agent, blacks and whites, heterogeneous agents in terms of the location, in terms of the race. And we are not going to do anything about it. It will be just left by themselves, and they will interact with each other, and eventually they will come up with this segregated urban space result. Okay? So what you can gather from this simulation and virtual experiments, meaning that only this segregation hypothesis we can come up with why a certain neighborhood is filled with one race and the other neighborhood filled with another race. That's what you can find out as a social scientist. So this is the very basic agent-based model. However, its impact was significant, and so that afterwards, now people are understanding, okay, so just neighborhood problem is not just economical, but rather it's coming from the racial bias and so forth, so that there are some laws to prevent such kind of prejudice in seeking housing and other renting house in US. So this is a simple introduction of how the Schilling segregation model works. And here we have an agent, and agents have some unhappy score based upon this formula, and this is number of neighborhoods with the same the race and divide by the different color and the number of neighborhoods. Okay, so that's the unhappy score. And what agents do? All the agents do here 1, 2, 3, 4, 5, 6, 7, 8. Eight agents will do is that this is the sequence of behavior. Observe the neighbors, calculate the unhappy score, and find the possible relocation positions. Maybe, okay, so I'm being surrounded by 1, 2, 3, 4 neighbors that does not share my skin color, so that I'm going to move here. Like that. So find the relocation place, positions, estimate the unhappy location there, and move to the best location. So these agents will move to there, and eventually will end up having this result. And next time, this is going to be an agent, and this agent has a perfect motivation to move from here to there, right? So that it will have a better unhappy score. And then this will move to other place, this will move to other place, and then the words will be separated, segregated. And before we go finish the conceptual discussions, I want to suggest to you that it is feasible to model agents in this way. So first, the cellular structure, automata is very nice model. It's very nice model to model the environment. Okay, however, it is being grid-shaped environment, right? And agent-based models are a little bit different from the environment model because it is moving around the structure and space. And then the cell structure and the agents model can live together like this, can interact with each other, so that agents will spell out the outputs, and that outputs will be received as an outside event to the cell structure of the cell automata, and it will change its own the state and so on, so that these types of the cell automata as an environment and depth model as an agents model is perfectly feasible to model the agent-based simulations. All right, now I'm ending the agent-based model, at least in terms of the conceptualized abstract discussion. And now I would hope that you understand the concept of complexity. For the complexity concept, you need to have in each individual model. However, individual model itself does not create the complexity, but rather individual collection of individuals and their interactions will create the complexity. Okay? So direct communications between each individual is feasible, or like the ant colony, indirect interactions through the space is also feasible. And also it's feasible to model the environment like the cell automata structure. So because of individuals' interactions, you can see that how the emergent patterns will come out from this complexity scenario. So this is the complexity part and conceptual part. However, today's model is really apart from a validated, calibrated models. It's ant-colony model. It's sugarscape model. It's just very abstracted segregation model. It's really different from the real-world models. Okay? For the real-world models, you need to put a more detailed behavior rules and states and details of the environment, so that those can be what? Those can be analyzed in your simulation model. I want to say keep it simple and stupid model. This is not a slang. This is a phrase, a perfectly valid phrase. This is a common word in the systems engineering field. Keep it simple, stupid model. In short, KISS model. Okay? And what we have been covered is the KISS model in this video lectures. These KISS model, keep it simple, stupid models, are actually grounds for many of those complex and real-world-like models. Why? Because that those real-world-like models will require a certain basis where we can grow upon. And often this KISS model provides such grounds. And these abstract models is really depends upon, hinges upon the analogies coming from the real-world observations. Insects, monkeys, children, or market participants. Insect rushing to the food. Doesn't it sound like the market participants looking for the profit? Maybe they share some of the common characteristics. That's why we are creating a conceptual complex model, so that we can make an analogy and do the analysis and get the insight and interpret that in terms of the today's real world.